Hello everyone, this is another video from Easy Electric series, and today we want to review some basic parameters for VFD. So we start with two useful basic parameters, P39 and P40. So P39 used for acceleration time, so that means with adjusting these parameters you actually tell the VFD how long it takes or how many seconds it takes your VFD increase the frequency to the max frequency that you adjusted. So the default, if for example, if you put 10 seconds, so that means whenever you started, it takes 10 seconds. Your frequency goes from the zero to maximum frequency that you already adjusted. So in the same way, we have another parameter P40, which it's actually give how much it takes to technically decelerate your VFD. For example, if that is 10 seconds, uh, whenever your motor is decelerate, it takes 10 seconds to decelerate the motor. But using the P40, you should be careful because whenever we use with in the previous video with we adjusted P37, if you remember, was the stop mode. We put on the coast, which means there is no ramp decreasing whenever you are stopping. So for sure, if that's on the one which is the coast, using the P40 is meaningless. So you should actually change these one to the zero. So that means back the setting to the zero. So then you use P40, which you give a deceleration time to your VFD. So if you use the remote potentiometer, what it means for that? So let's say we actually adjust acceleration. This is same for deceleration too. Let's just consider acceleration. So let's say we adjust that to the 10 seconds. So that means if the 50 hertz is your max frequency, so it takes actually 10 seconds that VFD increase the frequency 0 to 50 hertz. Now if you have the potentiometer and if you not change that number and move the knob of the potentiometer and put that to 25 hertz. So what it means? It means it's this time it takes 5 seconds to move frequency from 0 to 25 hertz. So that means it somehow is a linear. So if you decrease that number from the max frequency, it's linearly decrease. So this is actually one example of that. If the acceleration time is 50 hertz in 10 seconds, if you decrease with the variable resistor, so technically in the 5 seconds it should be beat in the 25 hertz that you adjusted with variable resistor. So let's go to our training kit and see how we could adjust these parameters in our training kits that we have.
Okay, so here we have actually the three wire settings. So we have start, stop. This is change the direction, and these variable resistor somehow control the frequency. So let's do check parameters P39 and P40, which is the P39 is for acceleration time and P40 for deceleration time. So before we test it, we need to actually make sure our stop mode is not coast. So come actually here, make sure you go to the P37. Okay, let's do just escape this. Let's do say P. Yeah, the P37. This is P37, and we check it. It should be on 0, which is a ramp. So which for my case is already is there, that's fine. So now I'm going to somehow go test the P39, which is acceleration time, P39. So I'm actually give that a big number that you see the difference, let's say 20 seconds. So what it means, it says the time that needs to move from zero frequency to the max should be 20 seconds. So I say enter. So let to see the frequency that you will see. Okay, I'm coming here and I actually push the start button and see. So the time that it should takes to go to the maximum frequency should be actually 20 seconds. For my case is 50 hertz. So you see actually it's slowly go up and in the 20 seconds it reached the 50. So now for seeing the difference, so let I just stop it again and run that again. You just get the sense of the 20-second that we adjusted. So see actually now I started again and see how fast is go up from 0 to 20. So as I mentioned, the time that takes from 0 to max frequency should be actually 20 seconds based on what we adjust. So now I stop it. So I come actually here, make that much slower. So let's just say P39 instead of 20. I'm going to actually give them, let's just say 4 seconds. And you see actually the difference of the, yeah, 3 is too slow, let's just say 4. And say okay. So now back everything to the frequency. Now see the difference in 4 seconds should be go to the 0 to 20. So I start here. Let to actually push the start and see how fast it goes. See the difference in 4 seconds and you get actually the 50 that you have. So as we mentioned, if you change the max of the frequency to smaller or to a smaller frequency, it's a linear. So now I'm moving from 50 to let's just say 25 and stop it. So if that's 4 seconds, 4 seconds I get to the 50, let's just say, yeah, let's see, let to run that again and see how fast it goes. So see, is the that I put on 25, which is a half of the 50, stop it. So if it's go 4 to 4 seconds from 0 to 15, so in 2 seconds it should be reached to 25. Let to start it and say time C 1 2. Yep, it's actually get that. So it gives you an idea about the P39. So let's to check P40. We should be the same thing. It is actually for the deceleration. So that means it's more about the stop. We could actually check here. So see here, let I increase this to maybe to the 50 with the variable resistor that I have here. It goes to the 50 and now stop it. So let I stop it and you see how it's slow. Probably is a 10-second there. It should be 10 seconds for deceleration. We could actually check that. So let's go to the cell. P40 is for deceleration time. So let's just see. To say escape. Cell, go up P. So then we say 40. So as you see, that was actually the 10. So these 10-second means the deceleration comes from the max frequency. Decelerate to the 0, it should be take 10 seconds. I'm going to increase that, which be much slower, that we see the difference. Let's do change A40 parameters to something maybe much slower. Let's say 40 seconds that we see how slow it is. I say enter. So now A40 is actually the 40. So see, I started which is 4 seconds. It should be go very fast to the frequency. It is fast. So now see deceleration time. So the time should be actually very slow, and you see we put on, if I'm not wrong, to the 50/40. See how slow it's actually going down because we adjust the P40 to a big number, so that means deceleration time is very slow and it goes all the way actually down, right? So now let's change it to something very fast. Let's see the difference. So comes to the cell. So let's say P4T. So see, that was 4T. I want to do that very fast. Let's say 5 seconds, that you really see the difference. Yeah, let's do just these, do that 5. Okay, say enter. So now let's see, there now should be very, for a deceleration should be also faster. Let's just see the frequency. So start, which we already know, should be very fast. 5 seconds, it get that to the 50. Now see the stop. So I stop it and see how fast is back to the 0, right? It should be 5 seconds. And you see the difference between this. So that means with P39 and P40, easily you could adjust the acceleration and deceleration time. So I hope you like this video.